Dear students, welcome to the second video lecture of session 5. We are going to learn about three concepts. Exploitation, which corresponds with local search, exploration, which corresponds with distant search, and ambidexterity, which means a firm's ability to conduct both exploration and exploitation. First of all, let us understand the concept of technology search. Search implies finding solutions to problems. One defining dimension is search space. Where does a firm search for solutions in relation to its own position? Should it search for solutions in technology space near its position, within its technologies and in the closely related technological domains? Or it should search for solutions in distant technologies which are new to the firm? Now the definition of two types of search. Local search is problem solving in the neighborhood of what is already known. That means in the domains closely related to organizations' already core technologies and to how the firm solved such problems in the past. Local search also means search for new but closely related problems to which a firm's existing knowledge might provide a solution. Distant search is problem solving outside the neighborhood of what is already known. Here, the organization solves problems that are new to it, or it solves problems that it has solved earlier but by using technologies that are new to it. Now let me explain it with an example. Let us suppose there is an automobile company which produces only petrol and diesel cars. It is searching how to improve engines efficiency. It is an example of local search. The firm has solved this problem earlier and it will look for solutions in its core engine technologies. Now, suppose that the firm finds that the technology is already on its limits and it is difficult to gain more efficiency despite much R&D. So the firm decides to produce electric cars instead. It is now searching how to store electricity for running the cars. The firm never solved such a problem before, and it cannot find a solution using its technological knowledge about internal combustion engines. So this is an example of a distant search. Now suppose that the automobile firm produces electric cars using lithium-ion battery technologies. It is searching how to increase the efficiency of electricity storage. The firm has already solved this problem in the past. It is finding solution in its core technology areas. However, it starts looking for recent technological advances scientists have made in the battery technology using carbon nanotube electrodes. Now, whether this firm uses this new technology in entirety or finds the solution by combining this new technology with its existing lithium-ion battery technologies, it is an example of distant search. So, distant search involves working on new problems, as in the first case, new technologies or new combination of technologies, as in second case. As you might have noticed, innovating along the same technology cycle is an example of local search. Shifting to a new technology cycle involves distant search efforts. Now, what triggers search processes in an organization? A firm engages in search processes when its performance is below aspiration. The aspiration level of performance depends on how the firm has been performing historically and how other firms in the industry are performing. Let us take an example. Google's ROA in 2020 is 15.57%, which is very high, normally speaking. Now let us suppose that Google's ROA in last 5 years was in the range of 70 to 20%, and Apple's ROA is 17.3%. In this case, Google might consider its performance below aspiration and then start searching how to improve its current technologies and products and how to dominate emerging technologies and product categories. Okay, so the second point, search is simple-minded and biased. A firm favors local search over distant search. It intensifies search to unrelated or distant knowledge areas when local search doesn't restore its performance. Now the question arises, why firms begin with local search? There are three main reasons for it. First, local search is a natural response to environmental ambiguity and scarcity of resources and time. Local knowledge is salient, easy to access, and cost efficient to use. So when firm is performing below its aspirations, its first reaction is to play on its strengths, work on technologies that it knows the best. Why to fool around in technology areas it doesn't know much about? Second, formal organizational structure and operational and financial controls drive local search. Formalization favors reliability and standardization, which typically result from local search. Third, over time, organizations develop a set of beliefs or a dominant logic which fuels local search. Sometimes even industries have a dominant logic. That is why you will see that technology firms hire top executives from outside the firm and sometimes even outside the industry. Now, the performance effects of local search. First of all, it gives higher mean performance. Working on your known technologies reduces the probability of your failure. But at the same time, it also reduces the probability of breakthrough solutions or large gains. Local search is efficient in short term. For a traditional automobile firm in the short term, it is optimal to search for increasing efficiency of its engines than searching for how to improve electricity storage. However, in the long term, the second search is optimal as it will help the firm to reduce carbon dioxide emission to zero. Third, local search crowds out distant search. When firms are cognitively and organizationally adapted to conducting local search, they become unable to spot and jump onto the next generation technologies and products. So why conducting distant search is so difficult? First of all, it involves a conscious effort for a firm to move away from its current core technologies and organizational routines, the way it has been doing things. It involves strategic change and managerial commitment at a higher level. Secondly, it involves serendipity and experimentation. It is irregular, unpredictable. The firm can achieve huge success, but there is also a high rate of failure. Second, when an organization is adapted for local search, it is difficult to conduct distance search. That is why many large organizations create spin-offs and separate units to conduct distance search in emerging technology areas. As you will notice in this week's case on Samsung, the organization in Seoul was more adapted to local search and tried and tested technologies. When Samsung decided to engage in distant search and become a technology pioneer rather than a follower, it had to create a new organization in Silicon Valley with different structure and culture. Sometimes firms are pushed to distant search. There are two major conditions when firms are forced to go to new technologies. First, when the firm faces a low performance, payoffs from local search are low. That means technology cycle is in maturity or stagnation phase. When local search efforts cannot restore performance below aspiration. Second, when an industry gets disrupted, the new product designs have emerged. Entrants drawing knowledge from other domains have an advantage. In these conditions, the firms are forced to move into the new technology areas. Let me give you an example. When 3G telecom technologies disrupted the mobile phone industry, many software companies like Apple and Google entered the industry and dominated it. So firms like Samsung and Nokia, which were heavyweights in hardware and were leaders in the times of 2G, had to do R&D in distant software domains. How firms undertake distance search? Going back to the case, how could Samsung gain knowledge in distant software technologies? First, by entering locations with distant knowledge resources, like Samsung went to and expanded in Silicon Valley. Second, by recruiting scientists and engineers specializing in these technologies. Third, by forming alliances with other firms, new ventures, and universities that specialize in software. Similarly, Samsung can acquire software firms and new ventures. And finally, Samsung can crowdsource distant solutions. That is, it can engage inventors outside its organizations and its research efforts. Now, prescription. A firm should embrace openness during industry disruption and focus on distance search. Let us again review the effects of distance search. It is uncertain, unreliable, and often takes a long time to emerge. However, it can help firms produce breakthroughs and novel and superior products. So it helps firms survive and perform better in the long run across generations of technologies. Another dimension to categorize search is by the heuristics. That means how does a firm conduct its search? First, it can engage in experiential search. It is an inductive approach. The firm engages in learning by doing. It takes actions and learns from the feedback. The other way is cognitive, which is a deductive approach. Here, the firm focuses on understanding and establishing causation. Therefore, it does learning before doing. If we create a 2 by 2 framework using search space and search heuristics, we get 4 types of learning paths as shown in this picture. When a firm conducts local search with experiential learning, it takes a situated path. Here, the objective is to refine existing knowledge and products through trial and error. The firm experiments in the neighborhood of previous solutions that feed back to firm's current actions. When the firm conducts local search with cognitive learning, it takes what we call a sophisticated path. Here, the objective is to understand a technological puzzle that the firm's scientists may have encountered. They use established theory to derive predictions that feed forward to their understanding of the technology. A firm takes an analogical path when it undertakes experiential learning in a new technology area. It uses the knowledge acquired in the distant field through trial and error to feedback on its current actions. Such learning often results in recombination of knowledge from the new technology and firm's core technology areas. At the end, the firm takes a scientific path when it undertakes cognitive learning in a new technology area. Here, the firm tries to understand the mechanism of the solutions in a new technology area in terms of causation. So it creates new theory using which it can derive predictions that feed forward to its understanding and multiple applications. This way, the firm produces breakthrough products and potentially create new industries. To understand analogical and scientific paths, let us go back to our example of the automobile firm, which works on lithium-ion battery technologies and is trying to improve the efficiency of electricity storage by searching into the new technologies using carbon nanotube electrodes. If the firm makes certain observations in carbon nanotube batteries and applies the same into its lithium-ion batteries with a hit-and trial method, noticing what improves the performance of the latter, the firm is taking an analogical path. So here the focus is on action rather than understanding. Instead, if the firm tries to understand the science of carbon nanotube batteries, how and why it is more efficient, or how and why the learning in this domain can be transferred or applied to lithium-ion batteries, it is taking a scientific path. In the second case, the firm is more likely to roll out breakthrough products and possibly a new category of batteries altogether. In this slide, I have listed some more research findings which I found useful for you. There is a paper by Rita Katila which explains what kind of knowledge helps firms innovate during industry disruptions. She finds that in such periods, a firm's knowledge in technologies which were till now core to the industry decreases a firm's R&D performance as this knowledge is obsolete and yet steers firms' search towards itself. However, firms' old knowledge in technologies which were peripheral or unrelated to the industry increases firms' innovation performance as it helps the firm create new combinations. So the practical implication: a firm should not only focus on R&D in technologies that are core to its industry, but also in other peripheral but related technologies. Another interesting research is done by Kaufman and his colleagues. He says that, or they say that, in early search for technological improvements, if a firm's initial position is poor or average, it is optimal to search far away on the technology landscape. But as the firm succeeds in finding technological improvements, it is optimal to confine search to a local region of the landscape. Now let us understand its practical implication by the way of an example. If a firm enters automobile industry and doesn't have a strong position in the core engine technologies, then it should conduct search in distant, possibly in emerging and futuristic technology areas. For instance, battery technologies. And if this firm succeeds in innovating in battery technologies and makes technological improvements, it should continue innovating in that technology area, battery technology itself. You will notice that firms like Huawei, which was a laggard in 2G and 3G technology, decided to invest in the next generation technologies, 5G, which was a distant search at that point. And over time, Huawei emerged as a leader. So, for inference, it makes sense to invest in the next generation technologies or distant technologies and disrupt the industry. They should leapfrog the incumbents rather than playing the catch-up game. Let me explain to you the concepts of innovation, exploration, and exploitation. Search efforts lead to generation of new knowledge. Innovation implies not only generating new technological knowledge, but also its commercialization. That is, its translation into new product solutions. So innovations are of two types. When knowledge is generated through local search along the same technological trajectory, the innovation is incremental and called exploitation. When knowledge is generated through distant search along new technological trajectories, the innovation is radical, very different, and called exploration. A firm is ambidextrous if it can conduct exploration and exploitation at the same time. Such firms compete simultaneously in mature markets where they gain competitive advantage based on their ability to conduct incremental innovations along the proven technologies, and in emerging and futuristic markets where they gain competitive advantage based on their ability to conduct radical innovations along new unproven technologies. As you can see in this week's case, Samsung is trying to be good at both exploration and exploitation. Firms follow a temporal pattern in exploration and exploitation. A firm, first of all, does exploration. It enters a new technology area. When it successfully creates a new trajectory, it follows exploitation. It refines the technology and the related products. For example, for years, BMW excelled in petrol and diesel cars. As the industry started shifting towards electric cars, BMW started generating knowledge in new areas such as battery technologies. It is an example of exploration. However, BMW doesn't leave this trajectory. Rather, it continues innovating along this trajectory to refine its products, and that is, it does exploitation.